No.
No?
You're good.
Oh. Okay. So we'll read the process, break it down just like you looked at for the previous parts. Stop, shuts everything off. Press start, milk pump runs for 6 minutes. Upon filling into the blend tank, chocolate pump runs for 3 minutes. Once milk and chocolate are in the blend tank, the agitator comes on for 15 minutes. If the overfill float's activated, everything shuts off. Perfect. We do our little chart for our inputs and outputs. Inputs. Outputs. Stop. Close. Start. Normally open. And then float. Switch. And we'll go normally closed. That way it keeps it easy. Go up, open the contacts. Outputs. We have motor 1. That's going to pump our milk. And we have timer 1. That way it keeps track of it running for the 6 minutes. What do you notice about the motor starters, and what are some of the additional components that we could use to keep this timer energized? Do we need a control relay?
Yes, you can use the motor starter.
You could use the motor starter, or we could have it with the control relay, right? Because the motor starter typically has a normally open set of contacts that are in parallel with what's starting it to keep that thing sealed on. So I'm just going to use my memory circuit from my motor starter and my timer and just omit the control relay because I have that part. In yesterday's example, we didn't have a motor starter. We needed the control relay for that component. We have M2, timer 2. That'll be for the chocolate for whatever 3 minutes, and we're going to pump it into there. And then our final, we're going to have M3, T3, and this is going to be our agitator. M1 for milk pump, M2 for chocolate pump, M3 for the agitator, all set by their basic times. Any questions up to that point? Now, predominantly, what's the use and the for utilizing the float switch? What are you going? Are you going to? Can anything operate if that other blend tank is too full, or is everything basically shut back down? So that way we don't overflow nothing, right? So what I like to do, I knock out my stop button first. So that way stop shuts everything down, follows my instructions, but also my float switch, right? So if stop or the float switch is activated, when somebody comes and presses start to make a new batch of chocolate milk, it's not going to work. So I knocked off those 2 inputs. Now I'm going to come to my start button. So what is my start button doing? It's turning on my milk pump. It's turning on our motor starter. And because it's going to remain on, we know we're going to have a memory circuit for a set period of time. So push start. M1 comes on. We have our overloads. Timer. M1 contacts. T1. T1 motor starter. And we'll just take it all the way to our L2 side. Press start. M1, our milk pump turns on. It's going to run for the 6 minutes that we outlined, and then it's going to shut that portion of it off, shut our milk pump off. Questions to this point? So what's the next step off of our process? Right now we push start, milk pump runs for 6 minutes, filling up the blend tank. What happens next?
Flow switch turns on.
The float switch is if we fill it all the way up, right? That's going to be, well, I put it in the beginning because if stop or the blend tank is full, nothing can work.
So the timer stops, opens up, and it jumps to the driver motor.
So it's going to turn on M2, right?
Yeah.
So right now we push start, the M1, our milk pump is pumping into the blend tank for 6 minutes. Once it's hit that 6-minute time, contacts are going to open, disable the memory, milk pump shuts off, but it does turn on the chocolate. So open set of contacts, that's going to turn on pump M2, which we call our chocolate pump. We have our overloads. To keep M2 on, what are we going to need to have? Well, you're going to need some form of a constant power to a degree, but you're going to need, what's the part of the circuit that we call that's going to keep it on? The memory circuit, right? So if I just do it like this, oops, M2, will it ever shut back off?
Yes, the timer goes 3 minutes and shuts off.
But where is that set of contacts? What are you going to, how are you going to disable it if it's drawn this way? Or what do I need to add to it?
The timer.
Add the timer normally closed contacts, right? So now we look at it, we re-go through our process. I'm gonna write milk, pump, chocolate, pump, and timer T2. Push start, our milk pump comes on for 6 minutes, pumping it into our blended tank. As it hits its set point, opens the contacts, disables the memory, milk pump shuts off, closes the contacts, turns on our chocolate pump, which turns on our timer, closes the contacts, seals the memory. So right now we've got milk pumped into it, chocolate pumped into it. Now what happens after we've pumped our chocolate in for 3 minutes?
You start the agitator.
Need to start the agitator. So what's actually starting the agitator? What set of contacts?
And three.
Timer 2.
Timer 2. Timer 2 is going, and is it an open set of contacts or a closed set of contacts? But if it was closed, well, because we know that M3 is going to be over here, right? There's our overloads again. So what's going to turn M3 on? If it was closed, would M3 already be on? Well, if M3, because we're looking for our L1 power, if you drew it like this, would it be on like that? Yeah, right? Because you're going to have a closed set of contacts go in that direction. So we probably are looking for an open set of contacts. Still T2 though, right? Because it's going through the process. Push start, milk pump comes on. It's pumping in our product into our blended tank for 6 minutes. Once it hits its set point, opens up the contacts, disables the milk pump and the first timer, closes the contacts, turns on our chocolate pump. Chocolate pump turns on, seals the memory circuit, timer's in parallel with the motor starter, everything's on and timing. It pumps in chocolate for 3 minutes. As soon as it hits its set point, that opens up, chocolate pump closes or shuts off. This T2 set of contacts is energized, turns on M3, but we want to keep it on for a period of time, right? We're going to mix up that chocolate and the milk. So we're going to need our memory circuit and timer. So now you've got it set up to where as soon as it's mixed for 15 minutes, it'll open up the contacts right here. Everything's going to shut down. So this, let's look at it, read it, evaluate it, and we'll answer any questions. If the stop button is depressed, can anything turn on? No, right? Because the power is going to stop right here. We have nothing going down L1 rung. So if this is open, no power is getting past that point. How about if we're not, where the stop button's in its resting state, but our blend tank's full. So now we have an open set here at the float switch. Can anything turn on? Not until we pump back out of that tank, right? So that it has a lower to allow the process to go. So this is just, hypothetical process just to get practice with it. So now we leave both of those along. Our blend tank, that's open. It's empty right now, waiting for the process to go. When I push start, energizes my M1 motor starter, closes the memory circuit, keeping it on. Because these two are in parallel, both of them are on at that same time and the timer is timing. Once the timer hits its set point, opens up the contacts, disables the memory circuit, all of that shuts down. T1 closes the contacts, our chocolate pump and the timer kick on, seals the memory, timer's timing. It's going to go through that process. And for whatever we put on there, 3 minutes, hits its set point, opens up the memory circuit, everything shuts off, closes T2's normally open set of contacts, turns on the agitator, agitator comes on, seals the memory circuit, timer's on, timer's timing. Once the timer hits its set point, opens it up, shuts off the agitator. Obviously, then we would have another tank that's full of chocolate milk, right? So then it would make sense that we would need to turn on another pump, take it out of that blended tank, maybe send it to a filling machine, send it to somewhere else. It's just what the main thing I'm trying to convey is break everything into little parts, relate it to stuff that you've already done, and then don't let me sneak one by you. If yesterday I called it a blending or for the gobstoppers, try to draw any similarities and then how the logic would actually be. Whatever we're doing with that process can all be manipulated by whatever you're going to be producing. The overall developing of the ladder logic really helps you out because when you start to see the patterns and similarities, I've done that before. That was very similar to this activity. And then you start to build more of these mentally in your mental math or mentally in your ideas so that you can set everything back up again. So thoughts, questions on how we took the written instructions, came up with the input-output chart, and then developed our ladder logic based upon that written set of instructions.
How does the reset?
Push stop or float switch.
Resets the whole process.
It'll reset it. It'll go right back to everything in its resting state as if nothing has ever been done. So if someone stopped it mid-process and you went and redid it, it would probably, because in my hypothetical item, I've got nothing leaving out of that agitator tank. If somebody stopped it and restarted, the pump would come back on and probably overfill it, right? So then our float switch would shut it down to prevent any mess. But this is not a whole process. This is just a couple little pieces of it that you can build onto based upon whatever you're going to be doing. Just, don't think of it, you can only apply it as a milk process, because what you've seen from when we looked at the notes from yesterday's, it's basically the exact same example. I just changed what I called the outputs, just to try and get you accustomed to mastering how to write the ladder, find those patterns, and then write up your ladder. So more questions, more thoughts, or any observations or comments on it? Cool. Okay, I'm gonna shut this off.